Quadratic function shown passes through 2, 0 and q0, where q is greater than 2. What's the value of q such that the area of R is equal to the area of region S? Well, let's first of all write down the quadratic. So it's a happy quadratic, but let me sort out the roots. So because I've got a root of 2, I'm going to get x minus 2 as a factor, and then also x minus q. Now, technically speaking, I would then need to times by a constant because there's an infinite number of quadratics that have these as roots. I could have one that looks like this instead. So I will leave that in. It's actually going to turn out that it's not important because as you scale it, it's not going to affect the fact that the areas are the same. And if you double it here and you double it here, for example, actually the areas just each double as well. But I've decided to leave it in terms of A. I think it's good practice to do that. And now I'm going to expand the bracket. So I'll get x squared, then minus 2x minus qx. Actually, it'll become minus 2 plus q times x plus 2q. And finally, ax squared minus 2 plus q. In fact, it makes sense to leave the a out, so I'm not going to worry about that. Right, now I want the area for R. And that is going to be the integral of this between 0 and 2. And the reason I left a out, actually, is that I can now just take it out of the whole integral because it's just a constant. And then this is equal to the area of S. Now, S will give a negative answer when you find the integral, so I just need to make it minus a times the integral from 2 to q, and then we're sorted. Then it's the same thing here. Okay, so let me focus on that actual integral. I'm going to get 1/3 x cubed minus a half 2 plus q x squared plus 2qx. And I can also say, because they're all equal, I can actually just now cancel out that a. So this, evaluated between 0 and 2, is going to equal minus the same thing evaluated between 2 and q. Okay, and we'll just keep going, substituting the values in. So let me substitute in 2. I'm going to get 8 over 3 minus a half times 4, so it'll be 2 times 2 plus q plus 4q. When I put in 0, actually, it's going to, I'm not going to get any extra terms. And that is then going to equal minus, and what I'm going to do is I'm going to, treat this as like, I can almost bring the minus in and put that a bracket and a bracket there. So I'll substitute q in with the minus, and I'll minus the same thing with the 2. So minus a third q cubed minus a half 2 plus q times q squared plus 2q squared. Then I will be minusing minus, then it's going to be the same thing as before, 8 over 3 minus 2. This looks pretty complicated, but hang on a sec. This ends up becoming a plus, and actually these then cancel out. So this just becomes 0. And therefore I can write down that a third, well, basically this is then 0. I can get rid of the negative, and we've got ourselves a cubic to solve. Okay, well, what should we do? Let's expand the brackets first, I think. So I will get a third q cubed minus q squared then I will get minus a half q cubed plus 2 q squared equals 0. So a third minus a half becomes 2 over 6 minus 3 over 6. I'm going to get minus 1 over 6 q cubed plus q squared equals 0. I'll times through by 6. I think that'll make things easy. Actually, I'll times through by minus 6. So q cubed minus 6 q squared equals 0. And suddenly this is coming together. I can factorize out a q squared. And I'll be left with q minus 6 equals 0. Now, we were told that q was greater than 2, I believe, at the very beginning. So it can't equal 0. And I can actually, therefore, divide through by that. And therefore, it follows that q is 6. It looked like it was getting pretty complicated and it all came together. So answer is E.